Hello everyone. In this session, we would be seeing and learning about local maxima and local minima. So, first of all, let us assume we have this graph. So, this is a very basic graph. So, what is? Let me extend this graph. Okay, fine. So, what is a local maxima and a local minima? So, local maxima is a point where if we go suppose we are at a point x is equal to c. Now suppose we go at a point x is equal to c minus delta, and we go at a point x is equal to c plus delta. So this is a graph. Suppose y is equal to f of x. Now if we go at a point, and this is x is equal to c. Now if we go at a point this x is equal to c minus delta. delta is Delta is a small value, and if we go at c plus delta, so at these 2 points, one minute. Yeah. So suppose if we go at x is equal to c minus delta, so if the value of f of c minus delta and the value of f of c plus delta, these both are less than f of c, then we say the point f of c is a maxima, and the function attains its maximum value at x is equal to c. So we say we have found the max c. Similarly, if find a point x is equal to b, suppose this is a point x is equal to b. Okay, so here if we go at a point x is equal to b minus delta, and we see a point x is equal to b plus delta, where delta is a small number. Okay, so if the value of f of b minus delta and the value of f of b plus delta, these both values are greater than f of b, then we say that the point f of b is a minima. So this is the very basic thing that we know about local maxima and local minima. Okay, fine. What is an important point that need to be noted while talking about local maxima and local minima is that a local minima is not the is not the leastmost value in the entire function. There can be a value which is less than this local minima. Suppose this point x is equal to b is a local minima. Now we see this value. Let us say this is x is equal to e. Okay, so this value is this value is even less than this minima. So a local minima is not the leastmost value in the entire function. Similarly, this is the maxima, and this is also a local maxima, but we cannot say this local maxima is the most is the greatest most value in the entire function. This is also a local maxima, but this maxima is less than this. So these 2 points should be noted in these 2 points should be kept in mind while knowing local maxima and local minima. Okay, so this is an illustration. For JEE, what we would be focusing more on is the methods to find local maxima and local minima. Okay. Now let us see absolute maxima and absolute minima. So first of all, I would be telling you the basic knowledge of absolute maxima and absolute minima, and then we would be going upon the methods to find these. So this can also be called as global maxima and global minima. So what is absolute maxima? Absolute maxima uh, is the value of the function that is the greatest among the entire function. Suppose we have a function f of x is equal to sine x. So we can say absolute maxima is equal to 1. It occurs at many points, but this is the greatest value of the function. Absolute minima is the least most value of the function, that at any point x, the function cannot go below the value of absolute minima. Okay. So how do we define absolute maxima? As a point x is equal to a is a point of global maxima for f of x if f of x is less than equal to f of a for all x belongs to D. Okay. So the where D is the domain of fx. So it basically says that the function f of a is the value f of a is the greatest value in the entire domain of the function f of x. Similarly, for absolute minima, we write the equation f of x is greater than equal to f of a. So these two equations, so these two equations are important. F of x is equal to is less than equal to f of a, and f of x is greater than equal to f of a. So these two equations should be remembered. Um, Okay. So till now we have seen this two equations for absolute maxima that we would be using in the questions. That is f of x is less than equal to f of a if we say a point is absolute maxima for the whole domain, and for absolute minima f of x is greater than equal to f of a for the whole domain x belongs to D. Now now we will see the applications on how to find maxima and minima of a function. So the first method to find method to find local maxima and local minima is the first order derivative test. So what the first order derivative test says? The first order test says that suppose we we know the function f of x. Now by seeing the slope of the functions, now by seeing the slope of the function, that is f dash x, we can tell that we are we having a local maxima or a local minima. So we know that at the point of local maxima and at the point of local minima, the slope of the function is 0. So we say that if a point, suppose x is equal to c is there, so at that point, the slope of the function would be 0. So we can write that f dash c is equal to 0. Now, since we know that this point slope is 0, so this point is local maxima or a local minimum. Now, how to comment that whether this point is a maxima or a minima? So suppose if f yes, sorry for the interruption. Suppose if f dash x changes its sign from negative to positive as x increases via point C, then we say that this is a local minimum. 1 minute.
I'm sorry for the disturbance. Um, yeah, in if f dash x changes its sign from negative to positive, then it is a local minima. And if f dash x changes sign from positive to negative, then it is a maxima. Fine. Now, suppose we see that there is no change in the sign of f dash x, then we say that this is a point of inflection, which is neither a local minima nor a local maxima. Okay. Now, what find local maxima or local minima is second order derivative test. Yes. Now we see second order derivative test. Now, what does second order derivative test says? Second order derivative test says, let us first find all the points where f dash x is equal to 0. So suppose there is a function f of x. So we will be finding all the points where f dash x is 0. Suppose we have got points x is equal to a, b, c, and d, where all these points, where at all these points f dash x is equal to 0. Now we will again differentiate the function. So we will see f double dash x. So if at f double dash x, if f double dash x is negative, then we say that point is local maxima. And if f double dash x is positive, then we say that point is local minima. If f double dash x is equal to 0, then we see that the test is fail, that the test fails. So we say that we cannot comment on that point, that whether that point is local maxima or local minima. It could be a point of inflection. Okay. So now there are some important points while suppose we want to suppose we have a monotonous function in the interval I. So in that interval we would not see any local maxima or local minima. And then suppose if we want to find absolute maxima and absolute minima. So suppose we have got 3 points of local maxima and 2 points of local minima. So, and we have a domain from -10 to +10. So to find absolute maxima, we would perform any of the above discussed. We will perform any of the above discussed points. Like we can perform the first order derivative test, or we can also perform the second order derivative test to find these points. After getting these 3 points of local maxima and after getting these 2 points of local minima in -10 to 10 domain, we will also see the value of the function at x is equal to -10 and x is equal to 10. Now suppose we have got the value at x is equal to 10 as f of 10 and at x is equal to -10 as f of -10. So we will compare these value of three maximas with f of -10 and f of 10 and see which is the greatest value. The greatest value among these five values would be our absolute maxima. Now we have 2 points of local minima. So we will compare these 2 points of local minima with f of -10 and f of +10. And among these four value, the least value would be our absolute minimum. So in this way, we can find absolute maxima and absolute minima. Now let us see some example. Here is an example which says find the point of maxima and minima of this function. So this is the most basic example. Here we can differentiate this function. We will get 6x square minus 6x is equal to 0. This gives us x is equal to 0 and 1. So these two are the points of this first order derivative test. Now we can see how this function f dash x changes its sign. to tell whether these are the points of local maxima or local minima, or also we can use the value of f double dash x to comment that these points are whether local maxima or local minima. So let us use second derivative test and let us find f double dash x. So in this case, f double dash x comes out to be 12x. Since f double dash x is 12x, so at x is equal to 0, f double dash x is 0. So we cannot say anything about x is equal to 0. Now, for f double dash x is equal to 12x, the value at x is equal to 1 is 12, that is positive. So that is a point of minima. So here x is equal to 1 is a point of minima. So the maxima of the function is at x is equal to 0. How can we say this? Since we do not have a proper domain, here we can see the point is here we can see like at my x is equal to minus infinity, the value of this function is minus infinity, and x is equal to plus infinity, the value of this function is x is infinity, y is equal to infinity. So there would be no local there would be no absolute maxima or minima. The value of absolute maximum and minima would not be defined, but surely there would be local maxima and minimas, where local maxima comes at the point x is equal to 1, and the value of local minima is 5 when we substitute the value x is equal to 1 here. Okay, now let us see this example too. Find the extrema of the given function and the extreme value using maxima and minima formulas. So whenever we see this term extrema, this the term extrema means global maxima or global minima. So they are asking us to find absolute, or let's say global. Let me say it absolute. So they are telling us to find absolute maxima and the absolute minima of this function minus 3x square plus 4x plus 7, depending upon uh, what of the two values, absolute maxima or absolute minima, exist. So we see this is a quadratic equation, and this is a downward parabola. So we can surely make the graph for this, and after making the graph for this, we find that there is no absolute minima. There exists a absolute maxima. So we would be reporting the absolute maxima for this point. So let us first differentiate it once to know the points of absolute maxima and absolute minima. After differentiating it once, we get minus 6x plus 4, and we get the value of x is equal to 2 by 3. So this is the critical point. So now let us differentiate it one more time to know whether this is a point of absolute maxima or an absolute minima. Since we know that this is a point of absolute maxima, we can also check it once more. Differentiate it once more and we get minus 6. So we know that this is the point of local maxima, since the double differentiative is negative. Now we will put x is equal to 2 by 3 in this equation. F of x is equal to minus 3x square plus 4x plus 7. We get the value 25 by 3. So at x is equal to 2 by 3, we get a local absolute maxima, and the maximum value is 25 by 3. Now there are some simple problems. There's this problem. The critical point of the function y is equal to x square is maxima or minima. So this question can be done by three ways. The first way is first order test, the second way is second order test, and the third way is using graphs. So by first order test, we can see that f dash x is equal to 2x, and this becomes 0 at x is equal to 0. So the critical point is x is equal to 0. The critical point of the function, now we have found the critical point of function as x is equal to 0, and they are asking it that whether this point is a maxima or a minima. Now to know that whether this point x is equal to 0 is a maxima or a minima, let us see it by the sign of f dash x, how it changes. So f dash is x is 2x, and we see that 2x for the values of x less than 0 is negative, and 2x is positive for the values of x greater than 0. So the sign of f dash x changes from negative to positive. This suggests that the point x is equal to 0 is a point of minima. This could also be done by second order derivative test, and this could also be done by graphs. So if you know how to draw the graph of y is equal to x square, you can easily directly say that this is a point of minima. Now, the second question says there can be any number of absolute maxima and absolute minima for a function within the entire domain. So this is true or false. So this type of questions have been coming in the recent mains exam. So like there were not many reasoning questions before, but now they are asking these questions um in the mains. So there can be any number of absolute maxima and absolute minima function within the entire domain. So this is like obviously false, because absolute maxima and absolute minima either exist or do not either do not exist, or if they exist, they are unique. So there cannot be any number of absolute maxima and absolute minima. So these are false. Okay. Now here are some more difficult questions on absolute maxima and absolute minima. Now the question says it is given that at x is equal to 2, the function x cube minus 12x square plus kx minus 8 attain its maximum value on the interval this 0 comma 3. Find the value of k. Now we know that x is equal to 2 is a critical point, and at x is equal to 2, this function attains its maximum value. So this can be done by differentiating it once, and putting x is equal to 2, and equating the value of f dash x is equal to 0. So we may solve this. So here we can see f dash x is equal to 3x square minus 24x plus k f dash x, and at x is equal to 2, we get f dash x is equal to 0. So we may write f dash 2 is 0. So on writing this, we get k is equal to 36. So this was a basic question. Now find the maximum value of f of x is equal to x cube minus 6x square plus 9x plus 15. This is also a very basic question, and it can be done by the same way we have done previous questions. Let us see some advanced questions. Okay. So there is this question, if the function f of x is equal to x to the power 4 minus 62x square plus ax plus 9 is maximum at x is equal to 1, then the value of a is. So this can also be done in the same way we have done first question. Here we would differentiate this function f dash x and we will write that f dash 1 is equal to 0. From there we can get the value of a. So here it is solved below. Okay, now let us see this question. The least value of the function f of x is equal to 2 cos x plus x in the closed interval 0 comma pi by 2 is. Now, till now we have been getting the questions where we are not specified intervals. Now we have been given intervals. So remember, whenever we get intervals, like we have to find the least value or we have to find maximum or minimum in a certain interval, and in those questions we find critical points, like we find the points where f dash x becomes 0. With them, we also find that what is the value of the function at the boundary of the intervals, like at the points 0, like here the interval is 0 comma pi by 2. So here we will also see what is the value of the function at x is equal to 0 and x is equal to pi by 2. So let us first differentiate the function. If f of x is 2 cos x plus x, then f dash x would be something like this, minus 2 sin x plus 1. Now we will put this f dash x is equal to 0 to get the critical points, to get the points where we can find maximas and minimas, local maximas and possible local maxima and a possible local minima. So when we do this, if we get sin x is equal to 1 by 2, and in the range of 0 comma pi by 2, we know sin x is equal to 1 by 2 at only sin x is 1 by 2 at only one value, that is at x is equal to pi by 6. Now we need to check that whether x is equal to pi by 6 is a local maxima or a local minima. Here we need to find the minimum value. So how are we going to check that f dash x at x is equal to x pi by 6, is this a local maxima or a local minima? So we will differentiate it once again. So minus 2 sin x plus 1 becomes minus 2 cos x, and cos of x minus 2 cos of x is basically minus 2 cos of pi by 6. So that would be f double dash x would be a negative value. It would be so since f double dash is negative, then the value at x is equal to pi by 6 would be a local maxima. Here we need to find the minimum value. So here we will also check the values at x is equal to 0 and x is equal to pi by 2. So at x is equal to 0, 2 cos x plus 1 would 2 cos x plus x would give us 2, and at x is equal to pi by 2, 2 cos x plus x will give us pi by 2, and at x is equal to pi by 6, f of pi by 6 would be pi by 6 plus root 3. So we surely know that pi by 6 plus root 3 is a local maxima, and we will compare the values among 2, pi by 2 and pi by 6 plus root 3, and we can clearly see from here that pi by 2 is the least value among these. So we will say that the least value of f of x in the interval is at x is equal to pi by 2 and the value is pi by 2. So this was a tricky question where they can directly ask us local minima by giving an interval, and students generally forget to check the values at the extremities of the interval. Now we will see this question number 5. And what this question number 5 says is, for a certain curve y is equal to f of x, satisfying this equation d2y by dx square. Basically, d2y by dx square is f double dash x, which is equal to 6x minus 4. F of x has a local minimum value 5 when x is equal to 1. The global maximum value of f of x if x belongs to 0 to 2 is. So here we have been asked the value, here we have been asked the global maxima, or we can say the absolute maxima for this function. And here we are not given the function f of x directly, we are given f double dash x here. So first we can see from here is that um, f double dash x is 6x minus 4 and f dash x would be 0 when x is equal to 1. So let us first integrate this function f double dash x, and we can know the value of the constant by replacing f dash 1 is equal to 0. So on integrating this, we get 3x square minus 4x plus c. So we get f dash x as 3x square minus 4x plus c, where c is a constant of integration. Now f dash x is 0 for x is equal to 1, because it is given that this function has a local minimum at x is equal to 1. By solving this, we can see that 3x square minus 4x plus c is equal to 0, and substituting x is equal to 1, we get c is equal to 1. Now we have got 3x square minus 4x plus 1, which is f dash x. And we know that x is equal to, and we know the value of this is 5 at x is equal to 1. So we will again integrate this. So let us integrate 3x square minus 4x plus 1. So it gives us x cube minus 2x square plus x plus c1. C1 is again constant of integration. Now we will substitute the value of x is equal to 1 in this equation, and we will substitute the value of y as 5 by the given equations. After substituting these two values, we get constant of integration as c1 is equal to 5. So we finally get the value of f of x is equal to x cube minus 2x square plus x plus 5. Okay. Now we have been asked the global maximum. Since we have given an interval x is equal to 0 to 2, the basic rule to find the global maximum value is, first of all, find the values at the critical points. Then we should not forget to find the values at the extremities of this interval, and then we will compare the values at the extremities and the critical points. So this can be done as the following. So here we know this is f of x, and if we differentiate it, we get f dash x as 3x square minus 4x plus 1, and this is a quadratic equation. And if we put it as 0, so we get two critical points, that is x is equal to 1 by 3 and x is equal to 1. So now we see values at x is equal to 1 by 3 and 1 by substituting it in the main equation, that is x cube minus 2x square plus x plus 5. So we get the value f of 1 is equal to 5, and at 1 by 3 we get some value, that is 13 by 27. Also at 0 we get the value 5 again, and at 2 we get the value 7. So you see we haven't got the absolute maximum at a local maxima. We got the absolute maximum here at the extremity of the interval, which is not a local maxima, like in this interval. So for the process of absolute maxima, this should not be forgotten that we have to check the extreme values. So the maximum value comes out to be 7. Now here is this another question where it is asked to find the minimum value of the function. Now this is again a basic question. Here we have been given a quadratic equation x square minus x plus 2. So this can be done by using graphs or by second order derivative test. So these basic questions would be easy and can be done in a very minimal time. Now comes the type of questions where we get functions like mod, signum, etc. So here I have given a function. What is the minimum value of the function? Mod of x plus 3 minus 2. So what is recommended here is, like, for these type of questions we should rely on graphs. We should know how to draw graphs for these questions. What else we can do is, uh, here we can here we can divide the interval of x to open this mod, and then we can proceed with our normal derivative test. But if we know how to make the graphs of this function, then that becomes easy. um, for uh, for doing it first, like, for the most basic solution, I would I would recommend you to use I would recommend you to divide the interval and then use the basic derivative tests to find the local maxima and local minima. So for x greater than equal to minus 3, for this value, the mod will open directly. So we will get the function as x plus 3 minus 2. So we will get x plus 1. And for x less than minus 3, we will get the equation, the mod will open with a negative sign. So we will get minus x minus 5. So we can check we can check for this manually. Also we can check it by induction. So it asks us what is the minimum value of the function mod of x plus 3 minus 2. So since it has not asked us the maximum value, basically it cannot ask us the maximum value because for this function the maximum value can be infinity. So since it is asking the minimum value of the function, so there are two terms. There is a mod term and there is a negative term, that is minus 2. So we know that the mod term would always be positive. So to make this function minimal, what we can do is we can make the value of the mod as least as possible, and we can keep the value minus 2 as it is there. So at which value of x would the uh, uh, would this function mod of x plus 3, at what value of x would this value mod of x plus 3 would be minimum? So we know that mod of x plus 3 can be minimum as 0. So it will happen when x is equal to minus 3. So basically we we substitute the value of x is equal to minus 3 here, and we get the minimum and we get the minimum value of the function as minus 2. Now we can also be given, now here is another question where we can also be given a function of degree 4 here. Doing this question from graph becomes a bit difficult. So it is advised that we do this question by using the first order or second order derivative test. Basically, we should do this function by using second order derivative test. So we'll differentiate this function and we will get 12x cubed plus 12x square minus 24x is equal to 0. Now f dash x can be factorized like this and we will get these critical points. Here we will also write f double dash x, and based on the values of f double dash x at these three critical points, we can comment that these are whether local maxima or local minima. Since at x is equal to 0, the value is negative, we will say the function attains a local maxima at x is equal to 0 and a local minima, and local minimas at x is equal to -2 and x is equal to 1. And here the question asks us the maximum value of the function, the local maximum value of the function. So we will say the local maximum value of the function is 12. The local maximum value of the function is 12, but it comes at x is equal to 0. So here it is asking it comes at which x. So we will say fourth option. It comes at x is equal to 0. Now this question asks us to find the local extreme value of the function f of x is equal to e to the power x. So the local extreme value of the function f of x. So this e to the power x function is an exponential function. So basically the local maxima or a local minima for this function does not exist, because here we cannot satisfy the condition that I have stated in the earlier part of the session where I told you that if we are able to find x that is equal to c, if we are able to find a x is equal to c for which for x is equal to c minus delta or x is equal to c plus delta, if we can say that f of c is greater than f of c minus delta and f of c plus delta, then that is maxima. Or if the equation is f of c is less than f of c minus delta or f of c plus delta, then the point is local minima. So for this function f of x is equal to e to the power x, we cannot find any such x. So we say that there exists no local maxima and local minima for the following function. Basically, this can also be seen by the first order derivative test or second order derivative test. Suppose let us differentiate this function. Let us differentiate this function as f dash x. So for e to the power x, f dash x comes as e to the power x, and e to the power x attains 0 at no value of x. So we can say this function does not have any local maxima or a local minima. Now this is again a basic question. Now this question says it is given that at x is equal to 2, this function attains its maximum value on the interval 0, 3. Now find the value of k. So this type of function is also done before. Okay, so there is this question. The center of the circle inscribed in the square formed by the lines x square minus 7x plus 12 is equal to 0 and y square. Okay, so this is not a, wait a minute. Okay, okay, let us see this question. What is the value of p for which the function f of x 3 has an extreme x is equal to pi by 3? So this can be done by first order derivative test, where we differentiate this function and put its value 0 by the equation as f dash pi by 3 is 0. From there we can find the value of p. So this is again a basic question. So you will find these type of questions in your JEE mains, and you will have to do these questions, like you will be able to perform these questions fast, like in 2 minutes or 1.5 minutes would be sufficient to do these questions. Okay, so these were the questions for local maxima and local minima. Okay, thank you.